Hello, and welcome to today's webinar, Using Test Automation for Continuous Test and Delivery. I am your host, Alicia McCullough. Our presenter today is Jeffrey Fortin, Product Manager for VectorCAST. We ask that you please remain muted throughout our presentation. If you have any questions, please feel free to chat them to me throughout the presentation, and we will have a Q&A session at the end of the demonstration. We will have a few polling questions in between. And again, just send me your questions throughout the presentation, and we'll get to them at the end of the demonstration. And with that said, I'm going to turn things over to Jeff. Jeff?
Thank you, Alicia. Always great to be here and to have you all here for our webinars. Today we're going to talk about test automation, continuous delivery, and we've got a really nice picture here of two really fast cars, and we can think about these cars heading down the road of getting towards a process where we can have a continuous integration process for improving quality in our software projects. So let's get right into it. Here's the agenda that we've got. I'm going to talk a little bit about how vector software plays in the continuous integration space, and then some of the things that we can do with continuous test and delivery using VectorCAST. And then, as Alicia mentioned, we're going to do 3 polling questions. And then I'm going to give you a little demonstration, gives you some examples of how we can integrate in VectorCAST with a continuous integration process. And then we've got, at the end, should have been Q&A on that last one, but that's the Q&A slide there. Okay, so how do we help our customers? One of the things, we're going to talk about 3 things in this slide, and the first part has to do with improving software quality. So with VectorCAST, our aim is to make testing easier, and we make testing easier in a lot of different ways. Testing by itself is not an easy thing to do. It's very hard to get requirements right, to understand how to test those requirements so that you're testing what the requirement meant to say. Sometimes requirements aren't defined very well, and we have to make some assumptions about what is meant by the author of the requirement. So testing overall is a difficult thing, and I've written a couple of blog posts recently talking about testing and the difficulty that we can have with testing. But one of the things that can make testing easier is to use automation to make the testing process go much more smoother. So when we make testing easier, more testing gets done. The less time it takes, the easier it is to do it, the more often and more likely that we will do testing. And when we do more testing, then we uncover quality issues that are in the software, and that results in fewer bugs getting out to customers. And when we have fewer bugs getting out to customers, that of course makes our customers much happier. And bottom line, happier customers make for increased revenue and brand loyalty. When bugs get out that have high visibility, it's a real tarnish to our brand and to our product, and we want to ensure that our levels of quality are high and that we are perceived in the marketplace as a provider of a quality solution. Reducing time to market, so this really feeds back to the making testing easier. By having continuous testing, what we do is we can identify regressions in the software much more quickly, and we can correct those things at a much lower cost if they are found at the time they are introduced. With change-based testing, we can reduce the cycle times for doing testing. So rather than having to go through our entire test suite for every software change, which is usually time prohibitive, we can just identify which tests have to be run according to whatever software has changed in the last check-in. When we reduce those testing cycles, then customers get features sooner. So we don't have to wait for us to go through the entire regression tests in order to release our software. If we have a release criteria that is set up, we can run through the tests that are necessary to make sure that we're meeting that release criteria, and we can get new products out to our customers sooner. And that, of course, gives us a competitive advantage. So with a quality system in place, it allows you to go fast without increasing the amount of risk that you have on the project. The reason why you've reduced the risk is because you are checking all of the things that have to be checked, but you're not checking things that don't have to be checked. And that's a real key differentiator, is making sure that it's not the number of tests that you're running, but that you're running the tests that should be run. And that's what a test automation platform does, like VectorCAST. And overall, these things are lowering costs. So the less effort that we're putting into software that should never have been written in the first place, the better off we are. Okay, the system has auto-magically advanced me to the next slide, so I guess we're ready to talk about the VectorCAST family of tools. And what you're seeing here are the tools that we offer for testing, and these are the parts of our test automation platform. We offer a system test product, which is our QA product, and with the system test product, we're able to automate your system testing, your system tests, and make it so that it's easier for really anyone to run the tests. And we'll talk a little bit more about what that means. We have unit testing solutions for both C, C++, and for Ada. And in addition, we have an analytics dashboard, which is a web-based browser. Alicia, for some reason, the slides are automatically advancing, so I'm not sure what's happening.
Yeah, you know why? Because it keeps going back to the agenda slide. I'm not quite sure why.
Okay.
So I'm just going to continue to push, you know, the slide that you're on to
okay, good.
the audience.
Okay, good.
But it keeps going back to the agenda slide, so I'm not quite sure what's up.
Okay, so we're on the family of tools slide and continuing with the dashboard and the analytics. So what the analytics is doing is collecting metrics about the software quality that we have and providing those metrics in a web-based dashboard fashion. And that allows really everyone to participate in the quality process and be able to see where we stand on our project. And then we've integrated a static analysis tool, Lint, into our product, and that's allowing us to do some checking to make sure that the code itself is structured according to our project standards, and maybe we have some outside requirements for checking of code, such as a MISRA requirement, which is common in the automotive industry. So Lint can be used to check those rules as well. So that's the VectorCAST family of tools. Okay, and we'll go on to the continuous test and delivery with VectorCAST. Okay, and now we're on the road to continuous testing. So when we talk about continuous testing, we talk about that in a number of different dimensions. So what you're seeing here is the software development process. And in that process, we can start off with our original code implementation, where we might be using some static analysis tools and checking to make sure that as we write the code, it's following the coding standards that we've set up for our project. And then we move on to the unit testing phase and the requirements testing phase, where we're checking against the requirements that we have. All of these different phases that you have in this continuum of testing. And with continuous testing, not only are we talking about continuous testing while we're doing our development cycle, but we also talk about continuous testing after we've deployed the software. Software rarely stays static over a period of time. We are either doing an enhancement to that software to add new features to it, or we're correcting defects that are in that software. So these are bug fixes. And those bug fixes and those new enhancements to the software require us to recheck the software and make sure that we've got at least the same level of quality in that software as we had before. So regression testing comes into play here, and that's all a part of continuous testing. So with continuous testing, we're constantly reassessing the software to see if it's meeting our quality standards. If we're in a development phase, we might be assessing the software to see if we're ready to do our new release. Do we meet our release criteria? If we're in a deployed phase, have we introduced any regressions in the software? So if we correct a bug, for instance, that was discovered in the field, when we corrected that bug, did we break something else? Did we have a regression in the software? And by doing this continuous testing, we're constantly rechecking the software, reassessing the quality, and ensuring that we have the level of quality that we want for our project. So how do we go about implementing a continuous testing process? And, I've got some steps here that I've outlined for implementing a process. At the outset, it can be daunting to try to set up a full, rigorous, continuous testing process that's, soup to nuts, everything that you would want it to be. And I think the very first thing you should do is just start doing some assessments of where you are at currently in your testing process and make incremental improvements over time. So some of the things that are easy to do is some of the things that you want to make easy to do are make sure that it's easy to build new tests. If it's easy to build a new test, then more new tests will be added. The more test points that you have in the software, especially if you can make sure that those tests are correlated to the requirements for the software, the better the software will be. Make sure that it's easy to understand the existing tests. So if you have a test, what is the purpose of that test? What are the requirements it's mapping back to? How is it that that test adds value to the system? By making it easier to build new tests and understand the tests that you have, you can improve the system and you can understand the system that you have so much better. Make sure that it's easy to run and interpret the results. So if you have a test result and it's ambiguous what a pass-fail means on that test, it's not adding much value. In fact, it's probably adding negative value to your overall quality process. So you want to make sure that when you run a test and you get a test result, that there's an easy way to interpret whether that's a good thing or a bad thing, whether it is improving quality or whether it has shown a regression in quality of your software. And make sure that it's easy to debug a failing test. So when a test fails, you want to make sure that there isn't just a report that says test 69693 failed, go fix it. You'd like to make sure that you have a way of capturing what the scenario was, what the environment was around that, providing information back to the development team so that they can recreate the failure, and giving them all of the tools that are needed to make a correction much easier. A short feedback loop between the code changes and the test results. So this really feeds in well with continuous testing. If we're testing at the moment that we make a code change, then we can know instantly whether or not we broke something that we didn't intend to break, okay? So if we have regression tests that are set up for interface testing, let's say, we added some code maybe for an enhancement or for a bug fix, and we recheck that code to make sure that it's still behaving properly. At the time that we do that software change, if we can assess that software and check to make sure that it's still doing the right things that it was doing before, we lower the cost for fixing anything that's broken because it's fresh in our minds. We know exactly what we just did to that code, and we can go back and correct those things that broke tests that happened as a result of that code change. Make sure that when we've got a continuous testing process that the results are actionable. So where are we in our process? What are the results that we have from the results of the testing that we've done? And what can we do to get better? Now, if you look at that little chart that graphic that I have over on the right-hand side, here are some metrics that you can use to identify where you're at in the current testing process. So here is just 4 of them. There might be, others that you could come up with as well. But a metric that is good to assess is time to test. How long does it take you to run through all of your tests? And you can see that little slider bar there. If it's over on the left-hand side, then it's taking a long time to run through all of your tests. And when it takes a long time to run through all of your tests, you're less likely to do the testing. And the less testing that you do, the longer amount of time it takes from a bug that's introduced into the system to the amount of time that can be identified as a bug. And of course, the longer it takes to actually fix that bug in the system. So you'd like to go from a long period of time, weeks, months, maybe several months to run all of your tests, to be able to run all of your tests or all of the necessary tests in minutes. The time it takes to run the test feeds right into the frequency of the test. Generally, the longer it takes to run the test, the less frequent you run them. So if you go from testing that's done per release, so we go through a number of sprints, increments, we've got collected a bunch of software changes that are needed for the next release, and then we go through our integration testing or our acceptance testing or whatever it is that we're doing before we do our release. And that's the one time that we reassess the software for quality. We can start at that approach, but we'd like to move that slider over to the right and make the amount of tests, the frequency of tests to go per change. Every time we make a software change, every time, not only in an increment, but during an increment as we make a software change, we'd like to reassess that software and make sure we haven't introduced any regressions. Who can run the test? This is very important, and we see this a lot, especially in the embedded world that we live in, is that test environments tend to be very complicated. Maybe there's specialized resources that have to be allocated, like boards or networks or IP addresses, whatever the limited resource is. There tends to be a small number of people who have the expertise who can actually set up and run a test. And sometimes that's a QA group or an integration and test group who have that specialized knowledge. What you'd like to do in a continuous test process is move that to an environment where literally you have a button on a dashboard and you say run the tests, and anybody can push that button, and when they push that button, the tests get run. That's what a test automation platform does for you. It allows you to create these buttons that allow anyone to run the tests on any time and for every single software change that you have. When you're at that level of sophistication, you've really got a good quality system in place, and continuous testing is a big part of what you're doing. In order to do that, you really have to bring in the last metric, which is the level of automation. If there's a large number of manual steps that have to be done that will directly impact the number of times that you can run a test, how much, that when you push that button, what exactly can happen when that button gets pushed. Is related to whether or not you have a lot of manual steps or everything is automatic. Now, it's rare that you'd have a case where everything is absolutely automatic. Generally, in order to completely test everything in the system, there are going to be some manual steps. But even when there are manual steps that have to be done, you can still add automation to that. Either use some sort of physical automation system, being able to have relays or actuators to be able to switch things on and off in an automatic fashion. So you're able to use relays and whatnot to be able to control physical systems through an automatic process. Or maybe it's just having a sophisticated scheduling system. So if there is a board or a lab or some piece of test equipment like an oscilloscope that has to be used in a particular test, find some way of scheduling that resource so that it's very easy for people to be able to set up these tests and use those limited resources that are needed for the few manual steps that you've got. So these are 4 metrics that you can move those slider bars, and you want to assess where you are on that slider and then put steps in place to start moving those sliders over to the right-hand side. Okay, the slides seem to be behaving now, so that's good. All right. So what can we do to make testing easier? The first bullet I've got there is eliminate manual testing. Now, as I just said, it may not be possible to completely eliminate manual testing, but there's a lot that we can do to reduce the amount of manual steps that you have in a testing process. We can use things like simulation systems in order to simulate some of the hardware, use virtual machines to be able to virtualize the test environments that you have, put things on networks. There's a lot that can be done to eliminate the amount of physical and manual physical entities and manual steps that you have in testing. And many of these things are very rigorous in the sense that when you test them in the virtual lab or when you test them with virtual equipment, the real equipment will behave in the same way. Now, it could very well be that you can't finalize the last release until you do the testing on the physical pieces of equipment. We see that a lot in the high integrity industries, but by using the virtual as much as possible, you can check things out that can be detected as a quality fault early on in the system. And then when you do your testing on the real physical equipment, you've got a much better chance of running through those tests, whether they be factory acceptance tests or qualification tests, whatever, or performance tests. Whatever those tests might be, they have a much better chance of passing if you've constantly run them in a virtual environment. Designed for testability. The time to think about testing is not once you've implemented all of the code. Think about not only the implementation of the code itself, but the way the code is architected. The architecture of the code has a profound impact on how that code can be tested. If you've set up components in the software architecture that have a lot of reliance with each other, that makes it very difficult to test them because it means that it's very hard to isolate in the requirements for any particular component in that architecture. You'd like to set up an architecture where the components can be easily broken off, interfaces identified, and the requirements for that particular component are well understood and can be tested independently of the other components. That way, when you get to integration testing, you can rely on the components themselves have met their requirements, and now all that you're testing is making sure that the interfacing between the components is done. And you can take that stepwise, refine that each way, and that makes testing so much easier. Now, there are software architectures and systems out there where there is a large degree of global data, for instance. We see this in the automotive industry where variants are generally implemented through a large global database, and that global data is shared by lots of components. So when you have an architecture like that, think about it in advance and find out or figure out how it is that you're going to test those components in that environment. So you know that is a design constraint that you have, that you have to live with that. Now put the process in place to make sure that you have a way of decomposing that and be able to test in that environment. So the ideal situation may not be the architecture that you have, but that just means that you just have to work hard to understand how it is that you're going to test in that environment. So as I mentioned, virtualized test environments is a very nice way of testing components before you get access to, or if you only have limited access to, physical test environments. The virtual environments can help a great deal to ensure the number of software defects that can be found in that virtual environment, get those out of the way, and then once you go to the live hardware, you don't have to worry about those things. Okay, so these are the steps that can be used to make testing easier, and if you follow these steps, then this makes it so much easier to come up with a continuous test environment. All right, if you remember back to the first slide that we did where we talked about making testing easier, we're not talking about making tests easier. Tests are hard to write. They have to be thought about and make sure that they correlate back to the requirements that are being written for that software. But the testing process itself can be made much easier through an automation process. And by using VectorCAST, what we're doing is we're giving you the tools and the platform to make testing, the test test process itself so much easier. And one of the things that we do to make that easier is we do something called change-based testing, something that we introduced a few years back. And it allows us to be able to track, as you run through your tests, what is the code that is affected by a particular test, right? So when we make a source code change, we can say, okay, you changed this module, or you changed this piece of the code. That and now makes, there were these 3 other tests that affected that line of code, and those 3 tests should now be rerun. Now you might have 300, 3,000 tests, but no code changes affected those tests. So by having change-based testing, what we're doing is reducing the number of tests that have to be rerun based on any source code change that you've got in the system. So that reduces the testing cycle because we're doing fewer tests, and it makes it much more likely that we will run tests, because if we've got just a small number of tests for a small software change, we're very likely to rerun those tests. And if anybody can run those tests, then that means that a developer, as they make the software changes, can rerun the tests. If an integrator gets a new module from a developer, that integrator can rerun the tests. Anyone on the team who wants to make a reassessment of the software can run the tests, and by doing change-based testing, they will only run the tests that have to be rerun based on any source code changes. Making test results actionable. So if we're doing a bunch of tests and we're collecting a bunch of metrics, is there anything that those metrics are informing us on our project? So it's nice to collect metrics, but you make sure that the metrics that you have are actually telling you something about what you can do to make your software better. The number itself is not so important. What the number is a action for you to improve the quality. So by collecting numbers over time, capturing historical trends, and maybe even correlating those historical trends with events that have happened in the project, those can give you some real actionable insights into how you construct software and how that software build or that software project works. So, for instance, you might notice some historical trends that as complexity rises in your software, the number of defects that are found rises as well. It's a common trend that you see in software. So you might say, okay, based on this metric and the trends that we're seeing in this particular metric, we're going to set a policy for our project to say that software complexity can't go over a certain threshold. So there we're taking an action based on metrics that we've collected over time and the correlation of those metrics with world events. And that, in this case, the event is the number of defects that we find on the software based on the complexity of the software. So metrics, it's a nice buzzword. Everybody talks about metrics, but we want to make sure that as we're collecting metrics, we have some action that results as we take a look at the metrics. Maybe we can put some alarms or some alerts in the metrics that you collect and say, hey, look, this is not meeting our quality threshold. Maybe our quality threshold is we want to make sure that before we release our software, we have 100% statement coverage, and we're now at 50% statement coverage. So that's a red flag. We need to do some steps to improve the amount of tests that we have on that software in order to get our code coverage metric higher. So that's the action that we would take as a result of seeing the metric of the code of the statement coverage that we have on a particular software project. So some examples of quality metrics that can be collected. You can do a logic complexity. So how many unique paths exist through each function of the code. The more paths that there are, it tends to make the code difficult to read. It can introduce unintentional effects in the software. So we might be collecting logic complexity as one of the things that we collect. And if the logic complexity tells us that that makes the code harder to maintain or harder to test, we might set a policy that says, look, logic complexity has to be below a certain threshold. Interface complexity. So if we have software functions that have lots and lots of parameters, are all of those parameters actually needed? Do we need to be passing all of that information back and forth between the software functions that we have in the system? Can we reduce that and make it easier to test? Because the more parameters that we have, the more test vectors that are needed to check those parameters and ensure that those parameters are being acted on correctly by the software. If we're passing information unnecessarily or information that's never used by that function, then can we take those functions out? Take those parameters out. Comment density. So some comments are, of course, helpful in any piece of code in any situation, but despite having the goal of having low logic complexity, there might be a piece of code that just inherently has to be difficult. It's a very complicated algorithm. This code is going to be hard to write, hard to understand. It's going to be a very complex piece of code. So let's write some comments around that code and make sure that the designer of that algorithm or that implementation clearly identifies what is going on in that piece of code, and that will make it so much easier to understand going forward. So comment density overall throughout the whole software implementation can help us with maintaining that code and ensuring that the code design stays true as we go forward over time. And then, one of our favorites, testing completeness. Let's make sure that we've tested at the very minimum all of the code that we have. If we've got large sections of code or even any section of code that no test case covers, then what is that code doing? Is that code even necessary to be there in the system? If it's never been tested at all, how can we ensure that the quality of that software is what we expect it to be? So at a minimum, we want to make sure that we are completely testing all of the code. And of course, what we'd eventually like to go to is not just testing the code itself, but ensuring that the code meets the requirements. So it's the code coverage as well as the requirements coverage that's very important with regard to testing completeness. Have we tested all of the code, and have we tested all of the requirements? All right, so those are some quality metrics that we can track. And so analyzing quality data, I mentioned that we have VectorCAST Analytics, which is a web-based dashboard. And what that dashboard is doing is providing us easy access to metrics that we collect as we go through our software testing and our software development. So all of the metrics that I identified on the previous slide can be gathered by VectorCAST and can be displayed in a dashboard format. I've shown over on the right-hand side just some screenshots, and in the demo I'm going to show you the dashboard itself. But there we've collected some of the metrics that can be collected by VectorCAST and displayed in the dashboard. Now, the nice thing about our analytics product is that it can also integrate in third-party tools. So if you've got data coming from a third-party piece, maybe you've got some sort of tool that you run and analyze your source code against. Maybe it's a static analysis tool. Maybe it's something else that you have. Maybe it's a security checking tool to make sure that there aren't security flaws in the code base itself, and you'd like to be able, and that collects metrics, and you'd like to be able to display those metrics in the same dashboard with the testing metrics. So you can integrate in those other pieces into the dashboard and see those side by side, and even correlate those metrics with the testing metrics that you have. And maybe there's a correlation between the two pieces of data that you'd like to be able to measure and assess as you go through the project. Okay, so we're already up to the polling question time, so I'm going to let Alicia take over here, and we've got some polling questions for you.
Okay, great. Thank you, Jeff. Okay, the first polling question that I have is, okay, how often do you ship software updates? Every month or less, quarterly, once or twice a year, more than a year between updates. Go ahead and plug your answers in. And please make sure to chat us any questions that you have while we're doing this. And we'll get to them after the demo portion. Okay, great. Go ahead and go to the next polling question. Are you moving towards more frequent software updates? Yes, plan to in the future, or no? Go ahead and plug your answers in. All right. Okay. Great. Great information. Okay. Next question and last question. Okay. Can anyone on the project run any test? Yes, no, not yet, but moving there. Go ahead and put your answers in. And then we will get to the demonstration. Okay. Got some great questions coming in, so please feel free to send them over. Keep them coming. All right. We are going to turn things back over to Jeff. Jeff?
Okay, thank you. I didn't see the results of the last poll. Did you happen to remember that?
We're having a little bit of a technical issue, Jeff, so
well, technical
we'll have to
glitch. Okay, so I got the first two.
Yeah.
So the first one was on updates, and I noticed that the most popular one was every month or less. So that's oh, okay, great.
Okay, can you see it now? Okay.
Not everyone can run the test is the most popular one. Okay, not everyone, but moving there. Okay.
Awesome. Okay.
Okay. So on the back to the updates. So every month or less. So that's good. That means that the projects that are going on, there's a high amount of velocity that's happening. Lots of software is being changed and moving through the system, so that lends itself to a continuous test and really a continuous integration environment. People are planning to go even faster. So right now, the majority of you said that you were every month or less, and you want to go even faster than that. So that's fantastic. That shows that there's a lot of need to have a continuous test environment in place to help you to get that faster. And right now, not everyone can run the test, but planning to get there in the future. So that's great, and that's what we would like to be able to do with VectorCAST and the test platform. So I'm going to push a button, and when I push that button, hopefully you can see a screen appear, and I'll just let it go through the buffering process and wait for you to be able to see that on your screen. As it comes up on your screens, you'll be able to see my desktop where I'm showing a browser, and I'm showing the Jenkins build server system that has been fitted out with some plugins that we develop here at for VectorCAST in order to make the Jenkins integration much easier. So just a little bit of orientation if you're unfamiliar with Jenkins. What you're seeing here is a web dashboard of Jenkins. In my case, I happen to have Jenkins, the build engine's just running right on my computer, but typically you'd have some type of a build server, and that build server would be a pretty powerful server that allows you to run a lot of things concurrently. So lots of build engines built into it to be able to make the whole build process and testing process much easier. So if you're not familiar with Jenkins, or even if you are familiar with Jenkins, one thing that you will know about Jenkins is that it has a lot of configuration options built into it. It's a very flexible environment, but because of that flexibility, it has a lot of configurable parameters to it. And setting up all of those parameters can be a little bit daunting. So that's why we created the VectorCAST plugins. And I'm just going to show you the list of plugins that we have. And the plugins are available right on the Jenkins site. So when you download Jenkins and install it, you can look right in for the plugins and take a look at VectorCAST, and you'll find our plugins there. And that way, you just have access to them right from the Jenkins site themselves, and they, follow the whole plugin infrastructure, so that as we update the plugins, you'll get notified that the updates are available, and you can install those updates in your Jenkins installation. So at the top are the VectorCAST jobs, and you can see what we've done is set up some steps for you to be able to create a single job or multiple jobs and be able to delete a job. You can do some things like a diagnostics just to make sure that you've got VectorCAST integrated correctly into Jenkins and things like that. And again, these plugins they have the configuration data already set up for them so that you can take your VectorCAST projects that you have right now and plug them in as is just into Jenkins, and allows you to run them. Once you've got them in Jenkins and the initial configuration has been set up, you might want to do some more creative things with them, and that's fine. What we meant with the job that we're intending to do with the plugin is to make it easy for you to get started with integrating VectorCAST into Jenkins itself. But you might want to do some more creative things or some more sophisticated things once you've done the initial work. So what I'm showing in my Jenkins is I've used those plugins to set up some of the projects that I have set up in VectorCAST. And you can see that I've got a single project set up here for a coupling project that I did. And then I've got this multi-project. And what multi does is, multi is a VectorCAST project that has multiple environments within it. So all of these environments were part of my VectorCAST project. And the plugin brings in all of those environments directly into Jenkins. Jenkins itself is giving us some really interesting information, even without doing anything, just taking a look at this list. You can take a look at the status information over here. So if I hover over one of these, I can see that for this particular multicast job, right now my statement coverage is at 30%. Branch coverage is at 19%. MCDC coverage is at 0%. So right now we don't have anything for MCDC. And you can see that there's a little thundercloud icon next to that. So it's just a little visual cue that says, look, this particular project is not in such great shape. We need to do some more things there to get that particular project in better shape. But then we've got some bright sunshine things as well. We didn't have any of the builds fail. So no tests were failing at all. So all 20 tests passed, and no builds themselves failed. So the build stability is very, very high. So that's good. That means that the tests that we do have are good, and the builds process itself is building good software. So those are some good things. So Jenkins is just providing that for us on every single one of the jobs that we've got here. Then we can see over here that, how long was it since I ran the last test. I ran them this morning, make sure everything was good. And you can see that all of these jobs passed. They all had success, and I never had a failure with any of these. If I had a failure, that would give me some good information. And I think one thing that's interesting here is the duration it's taking to run these tests. You can see that the tests are running. The individual environments themselves are taking less than 8 seconds to run, and then if I run all of the environment, only takes just a little bit under a minute to run all of the environments. So if getting to the point where you can say, well, can I just push a button and run the tests? These tests are pretty complicated. You know, they're not the most complicated tests that are in the world. You probably have tests that are more complicated than this. But, you know, if I'm just, a person who just wants to come in and run these tests, you know, all I need to do is take a look at this dashboard, you know, push this button, and all of a sudden, you know, I've got a build scheduled over here that will, you know, rebuild the software and rerun the tests all at the click of a button. Over here on the build queue, it's telling me everything that I just queued up and the tests that are being run. Now, on my particular system, I can run 2 tests at the same time because I've got a dual core CPU. But if you've got a sophisticated build engine, you'd see a lot more jobs here, and maybe you've even got a build farm where some of these things are happening in a over-distributed fashion. So getting back to the test automation and continuous tests, the ability for anybody to be able to run a test and to click a button and to be able to run the test. And that's exactly what we're doing when we're using VectorCAST with Jenkins. So if I take a look at, you know, one of the tests here that I've got, one of the things that's nice is all of the VectorCAST reports that we have, the HTML reports, come into Jenkins themselves, so you can just see them right here in the tool. If you wanted to look at one of the other reports, I've got all of the HTML reports that are showing up here, as well as the XML reports. And then if you'd like to actually see the execution of that, here's the console output that VectorCAST, showing the VectorCAST execution and all of the steps that were done. You could, if you had information about this, you can, you know, take a look at the GCC parameters that were used to compile this particular subsystem. You might notice, say, oh, gee, you know, I'm not sure that that's right. Let me take a look at that. But really, anybody can go in here and inspect this and make sure that this is a good build execution path. And we've got nice testing evidence that shows how we tested the software and the steps that were taken for that. So again, that's just all part of Jenkins. Let's go back to the top here. Looks like everything passed again. So within the last minute, we just reran all of that. Took slightly longer. I guess I'm doing a little bit more on this computer than I was doing this morning, probably because of the webinar that's running. Took a little bit longer, but still, you know, 10 seconds to run through all the tests and environments. Pretty good. Okay, so that's Jenkins, and that's how we can take VectorCAST, put it into a continuous test environment. Maybe I'm using Jenkins to rebuild my software, and I'd like to be able to, when I rebuild that software, I want to be able to run those tests. So all of those linkages can be created within Jenkins, and we can set up jobs to be able to rebuild, reintegrate the software, and revalidate the testing, all at the push of a button. All right, I want to show you something else now. It's a little bit different. We're going to move over to the analytics portion of VectorCAST. So here I'm showing VectorCAST analytics. And one of the things I mentioned about analytics is to make sure that you have a way of showing trends over time. And within analytics, you can see at the top, I'm showing these trend lines that are happening as I'm building the software. And what these trend lines are showing me is how is my software behaving over time. So you can see that when I started this project, I had some pretty poor results. There, over here, I've got some values. This is the number of tests that are needed. If I go to something else like the total number of tests that are in the system, I can see that, at one time I had 5, and then I added a test over here, so now I got to 6, then I went down to 5 again, and now I'm back up at 7, and that's the total number of tests that I have. So I can see, to me that's a little bit of an interesting point right there, is why did I go from 5 to 6 back to 5 again? What happened to test number 6, and why did it reintroduce itself? So that's an action, this metric is showing me information over time. I can take a look at this metric, and now I'm going to take the action to find out, why is it that a test was added and then it was deleted? That could give me some really important information about maybe requirements were changing, and maybe some things had to be updated. I think your screen might have blacked for a little bit, and it's back now, which is good. If we take a look at statement coverage, we can see that statement coverage improved greatly over time and stayed static for a while, then went up a little bit, and then look at this big dip. All of a sudden we went from 40% statement coverage to no statement coverage. I'd really like to know what happened at that point. Did something fail? Did we have something that caused all of our tests to not cause any coverage whatsoever? I'd really like to know what happened there. But the good news is that whatever happened in that event, things are now good. So as we're doing our software builds over time, we can see that things are staying on a 40%. So we're not having any regressions since we did the test back on October 25th. So as I mentioned about metrics, metrics are numbers. The numbers themselves aren't important. What's important with the numbers is what are the trends over time? What kind of actions can you take as a result of taking a look at those numbers over time? And what are the steps that can be done to improve the situation? Now, if our release criteria is to get at 100% statement coverage, and the statement coverage hasn't changed since October 29th, we're still at 40%, we've got a problem on this project. This line should have been going up over time and trending towards the number that we wanted for this project, which is 100%. So there's a lot of information that the dashboard's showing me about the metrics, and I can take a lot of actions based on how those numbers are showing up over time. And then finally, we're sort of running out of time, so I want to make sure we get to questions, is that, we can correlate metrics with each other. So the number of statements that we have versus the amount of coverage that we have for a particular system, we can take a look at that and then dive into it from a functional point of view and be able to take that and use this as a heat map to say, maybe this clear table function is something that we should really look at because it's got 0 statement coverage right now. If we added some tests for this clear table, we could get that statement coverage metric up much, much higher. As opposed to taking a look at this one, which is at 86%, that's got pretty good coverage. So let's focus on clear table and adding in some tests to improve the statement coverage for clear table. Okay, so that's the metrics, and I think we'll just stop there and allow for some time for questions.
Okay, Jeff, thank you. All right, so the first question that we have is, how do you collect interface metrics when using VectorCAST Blackbox testing?
How do you collect interface metrics when doing black box testing? So I'm not really sure what metric it is that you had in mind, the interface metric, but I'll just take a guess, and hopefully I'll hit upon what is meant by the metric that you're thinking of. So it could be that the metric that you're thinking about, it might be a coverage metric, and in which case, if you are calling a software function with a particular set of parameters and seeing how those parameters affect the code coverage, then what you can do is run through different test vectors. Maybe you have an enumeration type, and if you set in, the first enumeration type, that gives you 20% coverage. You pass in the second enumeration, that brings you up to 40% coverage. You go through all of the enumerations, and you're only at 50%. You're at 70% coverage, let's say. then that tells you that the enumerations that you have for that particular parameter aren't hitting all of the code that you have for that particular function. So, either you've got some enumerations missing, or you've got code in there that can't be accessed by the interface itself. Maybe that's what you were getting at. Is since you're doing Blackbox testing, you can see that through just by calling the interface itself, you're not able to get to 100% coverage. So maybe you need to go to white box testing so that you can now see more of the code and be able to access it inside the function itself, or maybe the code has to be restructured so that the enumeration parameters actually do get you to 100%. Hopefully that's what you meant by the metric.
Okay. Do we have support for C# and database-driven tests?
So C# is not in the list for VectorCAST. We have C, C++, and Ada, a number of different compilers for all of those, but C# is not a language that we have currently. And as far as database, sorry, what was the term again? Database what?
Driven tests.
Database-driven tests. So yes, absolutely. So
yep.
If you've got a database, let's just make it simple and say you've got a CSV file that has the parameter ranges that you have that you want to be able to test through. Yes, we can bring in that CSV file and use that to create the test vectors for a test environment.
Okay. Next question is, are there any plugins for Bamboo as well? If not, are you planning to add any?
We don't have plugins for Bamboo. I think our FAEs have some information that would be helpful for setting it up, but we don't have plugins for Bamboo, just Jenkins at the moment. As far as plans go, it's not in our short-term backlog that I've seen. So I don't know of any short-term plan that we have for doing it.
Okay. The next question is, the slides show Jenkins 1.0. Does it work in Jenkins 2.0 with pipelines and Blue Ocean?
Yeah, the version is not, we're not particularly sensitive to the version because we're following the plugin template that you have for Jenkins. We're not taking advantage of any of those new features themselves. The plugins are just setting in the parameters. So if you wanted to take advantage of more advanced features within Jenkins, you can do that without a problem. We're just not using them out of the box.
Okay, great. How does VectorCAST manage project? How VectorCAST manage project is updated from test cases? Not quite sure.
Okay,
what you mean by that.
Yeah, I think I understand the question. So if you've got test environments that have test cases within them, those test environments can be edited. There's a number of different ways to do that, but let's say that you're using the VectorCAST GUI itself to update the tests within that environment, and then manage is overall running the environments and the tests within that environment. So we're picking up the test changes that you make within the environment themselves. There are actually a couple of different ways you can do that, but one of the ways allows manage itself to be able to control the configuration of the environment. And that's really nice because it allows you to have the same test reused in multiple configurations. So if you have a test that's applicable to multiple software builds or multiple software environments, you can edit that test once, and now that test can be shared across multiple environments. And that's one of the big advantages that you get with using a VectorCAST project, is the ability to reuse that same test in multiple environments.
Okay. And another question: how the data is updated for VectorCAST Analytics Server?
So the server is getting the information from a number of places, but essentially there's a project database that we read where a lot of the information is kept. There's also a history folder, and I was using the history folder in the example that I did to be able to show you the trend lines. So when you go through a software run, what you're allowed to do is push to a history folder the results of that particular run, and by pushing to that history folder, it allows you to get the historical trends that I was showing. So that is just built into the command line interface for the server itself. So there's just a flag to be able to update the history folder with the latest results from your testing.
Okay, and Jeff, we have time for one more question.
Okay.
How good is VectorCAST at interfacing with commonly used requirement management tools? Is there a way of maintaining easy traceability from these tools to the VectorCAST tests?
Yeah, so within VectorCAST, we have something called the Requirements Gateway, and that Requirements Gateway is a very flexible interfacing mechanism between whatever requirements repository that you're using and VectorCAST. So we can import those requirements and be able to assign test cases to those requirements, and when you do that, we now can track how many requirements you have covered in that environment. And we also have the ability to export the test results back to our requirements repository. And we've just recently done a nice integration with the IBM CLM, and so that's available now in the new release for VectorCAST 2018.